These are solutions to Math 90 Exam 4. Okay, number one, the vertex you can find at x equals negative b over 2a. That is 2 over 2 times 1, or 1. Then I plug in 1. 1 is 1 squared minus 2 times 1 minus 3. It's negative 4. So the vertex is 1, negative 4. And then for intercepts, if I plug in 0, you get 0 minus 3 is negative 3. And then plug in y equals 0, find x-intercepts, x squared minus 2x minus 3, factors in x minus 3, x plus 1. So that gives me x is negative 1 or 3. So my x-intercepts are negative 1, 0, and 3, 0. Okay, so I have the vertex down here at 1, negative 4, intercepts of 0, negative 3, negative 1, 0, and 3, 0, and that's enough to show me the graph looks like this. Parabola opens up, just as we anticipated to do. Okay, number 2. My zeros are at negative 3, 1, and negative 5. So negative 3, 0, 1, 0, negative 5, 0. When x goes to negative infinity, y goes to negative infinity. We plug in a super big negative, negative a million. That's a negative times a negative times a negative. Negative times negative is negative. If I plug in a super big positive, x approaches infinity, y approaches infinity. If I plug in a million, that's positive, positive, positive. 3 positives multiplied together give me a positive. So right now I have point here, point here, point here, and goes to infinity on this side, negative infinity on this side. Then I pick a number in between 0. So between negative 5 and negative 3, I pick negative 4. Negative 4 plus 3 is a negative. Negative 4 minus 1 is a negative. Negative 4 plus 5 is a positive. Negative times positive is positive. So it goes up and then down. And then for 0, 0 plus 3 is positive. 0 minus 1 is negative. 0 plus 5 is positive, so that gives me a negative. In fact, it comes out to be negative 15. So I know it goes down. So the graph looks something like this. Number 3, x plus 2 squared, x minus 4. My zeros are negative 2, 0, and 4, 0. So negative 2, 0, 4, 0. When x goes to infinity, y goes to infinity. Plug in a million, positive, positive. So shoots up. Plug in a large negative when x approaches negative infinity, y approaches negative infinity. Plug in negative a million. Well, if you square something, it's always positive, but a negative million minus 4 is a negative. So a positive times a negative is negative. So the graph goes like this and like this. And all I need to do is what happens between negative 2 and 4. Does it go up or does it go down? I pick a number like 0. I plug in 0. I get 4 times negative 4, negative 16. So it goes down. So the graph looks something like this. Number 4, long division. So 27x to the 5th minus 9x to the 4th. Notice in the original problem, there was no x cubed. You have to put it as a 0x cubed, 3x squared. Likewise, you need a 0x minus 3. And there's a 3x squared minus 3x plus 1. Okay, so what do I multiply this by to get this? 9x cubed. Now, 9x cubed times this whole thing is 27x to the 5th minus 27x to the 4th plus 9x cubed. Subtract the whole thing. That cancels out. Negative 9 minus a minus 27, that's the same as plus 27, 18x to the 4th, 0 minus 9, negative 9x cubed, bring down to 3x squared and start over. So what do I multiply this by to get this? 6x squared, so plus 6x squared. Now 6x squared times this whole thing is 18x to the 4th minus 18x cubed plus 6x squared, subtract, that cancels out. Negative 9 minus a minus 18, that's negative 9 plus 18, 9x cubed. 3 minus 6, negative 3x squared, bring down to 0x. Do it again. What do I multiply this by to get this? 3x. Now 3x times this whole thing, 9x cubed minus 9x squared plus 3x, subtract. This cancels out. Negative 3 minus a minus 9, 6x squared. 0 minus 3 is negative 3x. Bring down to negative 3. Do it again. What do I multiply this by to get this? 2. Now 2 times this whole thing is 6x squared minus 6x plus 2, subtract, that cancels out. Negative 3 minus a minus 6, negative 3 plus 6, 3x, negative 3 minus 2 is a negative 5, that's my remainder. So plus 3x minus 5 over the original divisor, 3x squared minus 3x plus 1. 5, synthetic division, 1, 2, 2, 1, and a negative 2 here. 1 comes down, multiply, negative 2, add 0. Multiply, 0, add 2. Multiply, negative 4, add 3. So how do I read this? Remainder is 3, and my quotient is x squared plus 0x, but you don't have to write the x plus 2. So x squared plus 2 plus 3 over x plus 2. Okay, number 6, they're telling you negative 2 is a 0. So negative 2, 1, 2, negative 9, negative 18. 1 comes down, multiply by negative 2, add 0. Multiply, 0, add negative 9. Multiply 18, add 0. And in order for negative 2 to be a 0, then this synthetic division answer here should be 0. So now my original polynomial is x plus 2. How do I read this? X squared minus 9. And I already know x squared minus 9 is x plus 3, x minus 3. So the polynomial, original polynomial completely factored is this, and the zeros are negative 2, negative 3, and positive 3. 7 is similar to 6. They just give you one more step. So 2x to the 4th minus 13x cubed plus 7x squared plus 37x plus 15. Okay, they tell me negative 1 is a 0. So 2, multiply negative 2, add negative 15. Multiply 15, add 22. Multiply negative 22, add 15. Multiply negative 1, negative 15, 0 remainder. Okay, and I don't have to worry about writing this polynomial. Let me just go straight to synthetic division again. And they also tell me that 3 is a solution. So do synthetic division on 3. So 2 comes down, 3 times 2 is 6, add negative 9. Multiply 3 times negative 9 is negative 27, add 5. Multiply 3 times negative 5 is negative 15, 0. Okay, so my original polynomial is now, if negative 1 is a 0, then a factor is x plus 1. Likewise, here I have x minus 3, and I read this as 2x squared minus 9x minus 5, which is factorable into 2x plus 1, x minus 5. So my original polynomial now factors completely into x plus 1, x minus 3, 2x plus 1, x minus 5, and my zeros are negative 1, 3, negative a half, and 5. Number 8. Okay, turns out negative 2 is a real solution. So negative 2, 1 comes down, multiply negative 2, add 0. Multiply, well, anything times 0 is 0, add 4. Negative 2 times 4 is negative 8, add them up 0. So now my polynomial is x plus 2, x squared plus 4. Set that equal to 0. X squared plus 4 equals 0. That means x squared equals negative 4. So square root property, x is plus or minus the square root of negative 4, or I radical 4, or plus or minus 2i. So my zeros are negative 2 and plus or minus 2i. Number 9, f of x is 4x minus 4 divided by x plus 3. Intercepts, if I plug in x is 0, I get negative 4/3. Y is 0, put a 0 here. A fraction is 0 when the top is 0. What makes the top 0? A little bit of simple algebra, x is 1. So 0, negative 4/3, 1, 0. When x approaches infinity, y approaches 4. The trick for that is to divide top and bottom of the original by x. So I can write it as 4 minus 4 over x over 1 plus 3 over x. So now when x gets super big, either positive or negative, this is nothing, this is nothing. So I end up with 4. So a horizontal asymptote is y equals 4. Vertical asymptote, well, from the original, you can see negative 3 is not allowed. So x equals negative 3 is a vertical asymptote. So horizontal asymptote, y equals 4. Vertical asymptote, x equals negative 3. And let's see, when x approaches negative 3 from the left, so I come to negative 3 from the left side, y goes to infinity. So a number like negative 2.99999, that's going to be positive, that's a negative, so the quotient is going to be negative. Let's see. Sorry, so if I plug in negative 2.99, yeah, if I plug in negative 2.999, I'm doing this part. Sorry, so y approaches negative infinity, right? So that drops over here. X approaches negative 3 from the left. That's negative 3.001. That's a negative. That's a negative. Negative divided by negative is positive, so it shoots up. So here's my graph. Asymptote y equals 4. Asymptote x equals negative 3. Intercept, shoots toward y equals 4. Shoots down to negative infinity. Shoots up to positive infinity. And goes toward y equals 4. And 10. My boundary numbers are whatever make the top and the bottom 0. What makes the top 0 is negative 2. What makes the bottom 0 is 5. So 0. So put an open circle on negative 2 and at 5. Plug in negative 2, I get 0 over something, which is not 0. It'll say 0 is greater than or equal to 0. That's true. Color it in. 5 is not allowed, though. You're never allowed to divide by 0. So open circle here. Closed, open. Then it tests each region. Plug in -3 and 0 and 6. -3 plus 2 is a negative. -3 minus 5 is a negative. Negative divided by negative is positive. Is a positive greater than or equal to 0? Yes, that's true. Shade that region. Plug in 0. 0 plus 2, positive. 0 minus 5 is negative. Positive divided by negative is a positive. Is a positive greater than or equal to 0? No, that's false. Do not shade in this region. And 6. 6 plus 2, positive. 6 minus 5 is positive. Positive divided by positive is positive. Is a positive greater than or equal to 0? Yes, that's true. Shade that region in. So I write this as parenthesis. Remember, negative infinity and positive infinity always have parentheses. And negative infinity, comma, -2 bracket, because I'm including -2, union parenthesis 5 to infinity. Right, so these are solutions to Melham's Math 90 exam 4.